Welcome to the Infill Podcast, where we interview the most interesting members of the 3D printing and maker communities, live and with audience participation. And now, here is your host, Jonathan Levy.
Greetings, everyone. Really excited for today's episode, and we're going to get to our guest in just a moment. Before we do, one of my favorite sections of the show, you guys know it. What's Printing, Jonathan, brought to you by Octo Everywhere. You can see here, not a whole lot is printing. I actually spent most of the day trying to figure out the Carvera Air CNC, but you can see here I'm printing a ducting tube for a bed cooling system that I'm trying to design. And what's cool about Octo Everywhere is even if I didn't get time to run my printers before I leave the office, I just leave them running. They're running Octo Everywhere, and I can fire away my prints and monitor them using the gadget AI. I use it, as you can see, for most of my printers, and you guys can try it out for free. And if you decide to upgrade to a paid plan, you get a $25 credit. So thanks, Octo Everywhere. On to our guest. Today we are joined by Glenn. I don't know if he wanted me to say his last name, so Ski Bike Make. Some guests don't want their last names. And Glenn is best known for the Filamentalist project, which is a filament rewinder commonly used on the ARCF, but it works with most of the multi-material units out there. Glenn, welcome. Thanks for coming on.
Hey, welcome, Jonathan. And it's a pleasure and an honor to get to talk with you and get to talk with the community.
Yeah, we're really excited to have you. I recently talked about the Filamentalist, and I'm going to apologize in advance if it takes me a minute to think. I told Glenn before we hopped on today, my brain is fried today, as I said, trying to learn CAM. But we talked a little bit, and I said in a recent video that the Filamentalist kind of broke my brain, and it's such a clever design. I don't understand how it works. I'm sure we'll get into that. But first I want to understand about you and where you came from. How long have you been in 3D printing? Are you an engineer? Who are you a little bit?
Sure. Yeah. So I was a rural kid. I grew up in southwestern Washington on dirt bikes and duck hunting and stuff like that. But I was a pretty good student too. And so did a lot of drafting in high school. So I went on to college in mechanical engineering, got my degree in 1986, and started at Boeing. And I was working on nacelles and the thrust reverser things that flip out at the back of the jet when you start to land. And so I got, I was working on these old Intergraph CAD stations. It's just green vector stuff, you'd sit in a console, kind of like in a video arcade or something, like the driving the F1 games. That moved into working on interiors on 747s. And that at that time, and this is just a side note, but it might interest, some of the folks out there, I got trained in CATIA 3D solid modeling, and at the time that's Dassault Systems. It's the same people who do SolidWorks. Mm-hmm. And so that was about 1987 or 88, so it was fairly early in the true 3D solid modeling. Mm-hmm. That was fun and interesting. I left Boeing after a few years because I was in an engineering org of 80,000 engineers, and I couldn't really see my career ladder very clearly. Kind of became a. But it was a great company and a great product, at the time. So I married in that period, met and married a girl from Boise, Idaho, and being somebody who skied and fished and rafted and climbed and backpacked and things, Idaho was just phenomenal for the amount of resource and public land and everything. So I found a job in Idaho. We moved to Idaho in '89. That was with Micron Technology, which is just one of the big three for memory, flash and DRAM manufacturers, and unique in that it's the only American memory manufacturer anymore. And that job was process engineering in electronics manufacturing. So that was robotic pick and place equipment, doing surface mount on circuit boards and stuff like that. So I did that for a number of years, kind of worked up through management, got into clients, did a couple of expat assignments, one in Malaysia to start up a plant, and one in Belgium actually for a year and a half, which was really neat. My family had a chance, my daughter, who was only 8 months old at the time, my wife and I spent a year and a half in Belgium and kind of car touring all around that part of Europe, which is really cool. So I did that for a number of years, contract manufacturing and electronics assembly, OEM companies, couple. And then I came back to Micron in 2015, back to Boise, and into like a supply chain role and a few things, and did 10 years and then retired about 2.5 years ago. So I'm enjoying a relatively early retirement. I retired at about 58. But in that process, what got me into 3D printing was not my job. I moved away from design and classical mechanical engineering pretty early in my career, but around, I would say, 2011, something like that, 2010. We were living in Eastern Washington. I was working for a company there, and myself and a few other guys started a high school robotics team through First Robotics. And that gave me a chance to work with not only some really smart engineering and other people, but just some brilliant kids. And so we put the team together, and being very rural where we lived, it was actually a 4-H club. And there were kids from about 5 different small high schools in this rural community, wheat farming area. And within a couple of years, we were going to the World Championships in St. Louis. So it was a really cool experience. And that immersed me in more practical mechanical design. It gave me my first light exposure to 3D printing before I left that area and came back to Boise for Micron. So that was the first sort of taste of 3D printing. And we became empty nesters back here. And, I was kind of thinking about getting into it. I had so many hobbies, I was kind of avoiding it for time reasons. But ultimately, in 2021, I bought this open box Chinese printer called a Bibo. It's a dual extruder, just really simple but enclosed little printer, and started printing PLA and really enjoying it, really enjoying getting back to some of the CAD design experience from the old days. And it took me about maybe 4 or 5 months, and I decided I'd build a printer. So
cool.
Upgraded that printer to be able to print ABS with a better hot ends, and printed all the key parts for my Trident, and built a Trident. I think around 2022, early 2022, and loved that experience. Being a glutton for punishment, decided to then build an ERCF, and that was back in the version 1. And it was pretty cool design, but it was just, I think we all experienced with the V1, it was hard to get ultimate reliability and swaps with that thing.
Yeah.
So that actually grew me as a designer and a printer, just trying to improve, the reliability on the ERCF, which included creating a buffer called the Carrot Quiver buffer, which was moderately popular in the ERCF space. And then one day I got a message through Discord from a guy, username This Is Cam, and he was using the Quiver, and he had some ideas and some questions, and we started brainstorming. And I was already working on a new buffer, kind of a loop buffer project of my own. And I quickly came to realize that this Cam guy was brilliant, and he's a researcher at MIT. He researches with a team of like AI enablement of robotic manufacturing, something like that. But he's also a big-time hobbyist in 3D printing. So we started exchanging ideas, and he shared a video with me on a Chinese equivalent of YouTube, and that showed a rewinder similar to the Filamentalist. And it is important, I wanted to point this out, that this guy, Muzi Xiaoyang, he probably was leveraging someone else's design, but I leveraged his design. I saw some videos, there were some, STLs, tried to make this thing work, and it was a filament-driven passive rewinder. And it helped me understand, some of the basic concepts. It had some it had some issues around some of the design and some of the reliability, but it got us started. And Cam and I did a lot of brainstorming and collaboration until we got to something that started working. And so this was a couple years ago. And so I started up my own Discord channel, asked for a beta team, got like a half dozen makers that were just fantastic, with all the kinds of diverse experience. One of my key collaborators is a guy named Cheese Frog. I'm going to mention a few others. These are all Discord names: Biocax, Grafton, Mogi UK. You guys know him from the Happy Hair. He wasn't necessarily helping develop the hardware, but he was there all the way. Just when I had software related questions or ideas. And a guy named JC Flux, who was an MMU3 guy, who had some great ideas. He helped me develop the printed clutch. We'll talk about that a little bit later versus one-way bearing as an option. Okay. And there's a guy named IG Anakis in the Discord space. He's part of the Orca Dev team as well. And, these people were building, providing feedback, helping me do things like eliminate supports and just improve design and printability, and really great with collaborative feedback. And, a couple others from the ERCF team, Kinematic Digit, or Terrence, and a guy named Mariax, and those two pretty much run the ERCF project. Also just great resources helping with things like sensor designs and things like that. So I've been just talking a lot, so you probably have more questions.
I do, but it's one of my goals is to let my guests talk more. So I'm glad that you're not. I'm glad that you're not shy, and I mean that genuinely. It's like sometimes I get so excited, like, oh, I know that guy too, So in any case, I did have a lot of questions though as you were speaking, which is I didn't realize that the design was inspired by another design, and I think that's kind of a testament to how these things work and how these projects are. Tell me more about. Well, I think first we should establish, and I should have done a better job saying this. What is the Filamentalist in your words, right? I called it a filament rewinder, but what is it? What does it do? And then I'd love to hear about, one-way bearing versus clutch.
Sure. So the Filamentalist is a rewinder used for multi-material printing. So, for those who do multi-material printing, this is obvious. For those who are considering it or want to learn more about it, then you may not, know this, but when you swap filaments, you have to eject the existing filament, and depending on that design, that ejection of the design of your MMU solution, that ejection could be just 100 millimeters, or it could be 1,500 millimeters, depending on how long your Bowden path is. My Bowden using an ERCF, even though the Filamentalist will work with an MMU, it will work with a trad rack, it will work with basically any multi-material system that needs buffering. In my case, I needed to eject about 1,100 millimeters of filament. That was the length of my Bowden on my Trident 350. And so in the past, we were always ejecting into loop buffers or slot buffers or things like that. And I was really wanting to be able to eject right back onto a spool. And I was working on that when Cam pointed me to the Muzi Xiaoyang solution.
Got it.
And so what it does, there's no motors. It basically, at the spool, the mechanism grips the filament, and as the MMU ejects that filament, it's actually driving the whole system, because that filament's stiff and it's constrained in the tubing. It basically is driving it right through a grip point in the rewinder, which makes the spool turn and makes it wind back up.
So that's the part that I've never understood, though, is how come, what's preventing it from, I wish I had a spool handy right now. I guess I do. Technically, it's connected to a printer that I'm not allowed to show, but, oh, come here, you. What prevents it from just going like that, right, and becoming loose?
Because, the wheels are driven, and maybe this would be a good time for me to do a screen share. Let me do a quick CAD screen share.
Yeah, please.
and we'll do that. And so we'll just hide a few things here. Okay. All right. So the filament is coming through the ECAS here. So your tubing would run out here.
Mm-hmm.
And in the share, are you able to see my mouse, Jonathan?
Yes, sir.
Okay, good. Because I'm using it as a pointer. And this is the one-way bearing, this silver thing here. This is a metal shaft.
Mm-hmm.
And these black guys right here, these are O-rings, and they create a nice grippy surface. Let me hide that rubber band. They provide a nice grippy little trench, okay, for the filament to rest in. And this arm is spring adjusted for tension. So when you're ejecting, the filament is rotating what I call the center drive roller. In this example, in a counterclockwise rotation. And it's the one-way bearing then locks on the shaft, which then makes these drive rollers, or what we call rim rollers, actually roll. So it's actually driving the spool as it's rewinding. Really, the big technical challenge to overcome here is that you have a variable number of rotations to turn the spool depending on how full or empty the spool is. And essentially, you need 2 times more rotation to take up, let's say, a meter of filament on an almost empty spool as you need on an almost full spool, right? Because your circumference is so much larger on a full spool. So I think, like on my Polymaker spools, they run from about 190, 185 millimeter diameter full down to about, I think, 95 diameter, 95 millimeter diameter, almost empty. So the gear ratios here, basically the difference between the diameter where the filament's gripped, that's about, 32, 33 millimeters, to this point, this roller that the rim sits on, that's about 65. So there's about a 2-to-1 difference. So essentially, we're overdriving a full spool. It's trying to turn more than it needs to, and that creates drag and tension and issues that could cause problems with your MMU. And the way we overcome that is this spring-loaded tensioner system will actually lift. So as the filament comes down and tightens as you're overdriving, it creates an upward lifting pressure on this bearing, this little bearing right here that's pinching the filament down against the grip.
Jeez.
So you actually set this spring pretty light, which is one of the first mistakes that users will make, is they think they need to crank this sucker down. And in reality, it takes a pretty light setting to get sufficient grip to drive the mass of a full spool, the rotational inertia, overcome that. And then you want it light enough that as it's overdriving and the tension of this filament coming through this path right here will lift this mechanism. It pivots at this point, lifts this mechanism, and it starts slipping. And then as soon as it slips, it drops back down. So basically it creates a modulated gearbox, so it can go anywhere from 2-to-1 to like 1-to-1 just by modulating up and down, slipping, gripping, slipping, gripping, slipping, gripping. And it works amazingly well. And actually that's kind of where the magic is yes, the one-way bearing's cool. It's really there to remove all or most drag when you're feeding, when you're printing or loading. It, the MMU and the extruder motor are ripping filament off your spool, and everything wants to rotate in a clockwise orientation. Well, that unlocks the one-way bearing, and so you're not dealing with any of the drag associated with this spring system or anything else. So yeah.
And just so I'm clear, the one-way bearing is I'm trying to get my head around it. The one-way bearing obviously allows the spool to be pulled and unrolled. Why do you need it to lock in this way? So that it's so that the filament can turn that whole assembly. And when the filament
That's right.
I get it. It just clicked for me.
Yeah. So when you're driving this assembly here,
yeah,
that is locked. Forcing the one-way to lock against this shaft, and then these rollers here are hard attached to this shaft. So then
Crazy.
it's driving those wheels.
This is
And
a crazy
what
thing to design. It's like a really, really, really clever. And you got to think like, I mean, there's some pretty good engineers at Bamboo, Creality, Prusa, and no one thought of this, except for this guy that you mentioned.
Yeah, different people were trying different things. So it wasn't really a unique idea. I'm not that smart. And in fact, most of my innovation has always been, like I think most people's innovation is, off the backs of other smart people. And so, I was synthesizing ideas, and I was going in a totally different direction when I started playing with this. And at one point, Cam and I actually got a belt-driven version running. And so the spool would sit on two TPU printed timing belts, essentially, G2T timing belts. The whole spool would sit on that, or the filament roll would. And that way, as the filament roll reduced, since it was sitting on those belts, it always turned the right amount. So that actually worked. It was ridiculous looking. The spool wanted to flop all over the place. Sometimes the belts would get kind of like wedged into if there's any loose packing on the spool. And ultimately we ended up with the solution that was an evolution from the one that we saw from Muzi Xiaoyang. So then, and I just kind of wanted to put in a plug for this too. This was months of development. This was trying different things, failing fast. And I'm kind of passionate about, you don't just post something out there until it really works well. Mm-hmm. And not to bash, but you go out onto printables and stuff, and there are a lot of things where people did something that had a pretty good idea. They're in love with it. They post it for the world. They give it a really cool write-up. You build it and it doesn't work,
Yeah.
And so in my first year of working with the ERCF V1, I tried building one of the printed spring rewinders, universal spring rewinder thing, and it almost worked. It always almost worked. But there was too many conditions, whether it was cardboard or plastic spool, whether it was almost empty, almost full. There were so many different variables that design just, for me, couldn't overcome. And so I was sensitive to that. And so when I've released my projects, I usually try to test them, to get a few people to test them,
which is so much work, by the way. It's so much work.
It is. We beta tested, I want to say 4 or 5 months, and then, opened it up and started getting traction. And then we still got good ideas, right? There was still several iterations of just improving, mostly things like printability. Just people would come in with good ideas and good experiences. And that was kind of the beauty of, I was operating out of my own Discord channel at that point, but either that or the ERCF channel. It's brought in people from the Solvol space, the MMU3 Prusa space, the TradRack community. It's brought in all kinds of different people kind of into this environment who have different experiences and ideas. And so I've really appreciated all the engagement, all the positive, feedback, and people not being afraid to be critical, because it's a very, safe space that we operate out of. And it's really helped evolve the design. And so we had rolled out something I call the Classic. I'm actually going to share a different screen now to talk about that a little bit. Okay, here we go. So this is the Discord page. It does sit underneath the ERCF V2 Discord, and there's 3 projects under this page. There's the Classic, which was the original released design, the Filamentalist FV3, and then the Filamentalist Enclosure. And
really
so cool. The Classic, I still support it today because it actually functions as well, if not maybe slightly better than the V3. just through some of its geometries. It's a little frumpier, but it works fine, and a lot of people have built those, and so I continue to support that version of the design. And I had both versions in this enclosure. During the classic period, a really nice, cool guy named V6CL on Discord, he came out with one he called the F1, and it looked a lot like the FV3, F1 like the race car. And it had a center solid chassis, and it had these cantilevered spools. And I ultimately added it to my user mods under the ERCF V2. A lot of people built it and liked it. But then we started to find a few small issues in the design. It wasn't perfect. He had moved on to some other solution or got out of multicolor printing or something, so he wasn't really supporting it. But he gave me some great ideas. And so the V3, I leveraged his cantilevered wheel design. And the main thing that gives you is that you can basically get a wider spool capability in the same space as the classic, because you give up a certain amount of width for these outboard chassis parts. And I kind of wanted that because I run a 6-channel ERCF. I run a Trident 350, so these are 500 millimeter wide extrusions on the enclosure, so there's only so much you can sandwich in.
Yeah.
And for my Polymaker spools, it fit fine. But there was a few other brands of spools, KVP, some Fusion stuff I had, Ninja Flex, and we'll talk about TPU later, that just didn't quite fit. And in this design, now I can get this out to about 74 millimeter spool width. So for 1 kilogram spools, that covers probably 98% of the major suppliers out there, if not 100%.
Now, you showed the enclosure. How the hell are DIYers doing that bent acrylic? That was the first thing that jumped out at me.
We'll talk about that. I'll share a different screen if you don't mind.
Sure.
We'll go back to CAD.
Well, I mean, we see it too on screen in 2 different angles. Oh man, I'm falling apart.
Oh yeah, that's true. Okay, the enclosure, the key to this is that this is polycarbonate, not acrylic, and it's only 1.5 millimeters thick. So it's quite flexible. And so you're able, this is, getting this lid together is not a small task. It's not really because it's so hard to bend that acrylic, or that polycarbonate. We're not applying heat or anything. We're just building it in the slots. It's just you need about 5 hands to do it. So
right. So it's under tension basically, or flexion at all times.
Exactly. Yep.
Okay, that was the first thing. I was like, how the hell is he doing that?
Yeah.
That's really cool.
Some people have had trouble getting 1.5 millimeter or 060, 0.060 inch thick polycarbonate. I can get it off of Amazon, but US Amazon is not the same as what you can get in other countries. So some folks have done it successfully with 2 millimeter. There was a guy who made one with 2 millimeter, and he made it much, much longer. I think it was a meter long. It was twice his length, and he got it all together. It wasn't easy, and he's standing back admiring his work, and about 10 minutes, the whole thing just exploded, pop, and broken plastic flying everywhere. So, what I like about this 1.5 millimeter is you can cut it with scissors, like big hardware kind of heavy duty scissors. So you don't need any special cutting. You don't really even need to use a Dremel to cut it, and then you get that flexibility. And of course, 1.5 millimeter polycarbonate in all practical aspects seals just as well as a thicker material.
And it looks like it's open on the bottom. Is it ports into the printer to use the heat from the printer? No, it's closed. Okay, so it's sealed.
Well, mine actually is sealed against the top of my printer, but not everybody's going to put it on top of their printer. So so for mine, I set it up so it could sit right on my top panel, and I have
Cool.
weather stripping seals that sit all the way around this, and then kind of have it screwed down. And that's worked beautiful. And I do get a little heat from the printer, but it doesn't really do that much.
Yeah.
I
Really quickly, I
will
do have
say,
to.
though,
Oh, sorry. Go ahead.
well, I will say it's a bit of a pain in the neck to jam in all the seals and weather stripping and stuff, but
Yeah.
it just takes patience. And I think that's actually true for any enclosure. You got to seal it somehow.
Totally.
And so it's always kind of tricky to get the seals in.
Totally. So really quickly, I'll just take a moment and thank our other sponsor for the episode, which is PCBWay. You guys have heard me talk about PCBWay for many years now, but I use them for all the things because sometimes you can't or don't want to figure out CAM by yourself, and they can just CNC the part for you and send it to you, or maybe you don't have the capability to 3D print MJF nylon. Whatever it is you need to get done, they will just do it for you, and they'll even check the part to make sure that there's not going to be any manufacturing issues with it. One time they told me, hey, these holes are too small, the metal's going to heat and it's going to warp, and that's not going to work, which I thought was really cool. For the price, it's unbelievable that they have a real-life engineer check every order. So check them out, and you get $5 off your first order with my link. I hear some tool changes. Let's see, you're still screen sharing.
I just fired that up, and we can let that run in the background. Is the
cool.
camera working on that? Okay. And that's running, I think, 400 millimeters per second speed and 400 millimeters per second acceleration. If you have an MMU, it's less about the Filamentalist and more about the total drag and total grip in your system. So if you have relatively short mountain paths and you have a trad rack or an ERCF or whatever that you can achieve decent grip at the MMU gears, this thing can rip. So we've ran this thing at 1,000 millimeters per second.
Wow.
I ultimately slowed mine down because it was so noisy, it was startling.
Yeah.
Like I'd be in the other room, and my wife would have to hear it. And in reality, there's way more time spent in the purge. Like right now, I'm doing my own Blobifier software-only purge here. I don't use purge blocks or purge towers. I use blobs, and then flick them off the plate into a little box. But the whole change is like 45, 50 seconds or something. So the difference between running 400 millimeters per second and 1,000 millimeters per second, I was only shaving a second or so off my total tool change. It was really already 50 seconds. So I've slowed it down. It's slightly more reliable when it's slower. It's quieter, and because it's quieter, it feels like it's less wear and tear.
Tell me about this blob thing, because I've been told that blobs save a lot of time because you don't have to actually print a purge block. How are you flicking, and also where are you flicking to in a reliable and predictable fashion without a servo?
Okay. I'll move the camera in closer.
Okay.
There we go. There's the blob.
Oh, you have it just purging,
There's the
literally, for our entertainment?
Yep.
Interesting.
I'm just running two different rewinders, doing a script that's just going from one tool to the next. Now, if we look down below, you should be able to see. Let's see if I can find it.
It's on an angle.
Yeah, there's you have a little box. There it is. That's a little box that's catching my blobs, and it's on an articulated arm. So when the plate is up high like this, it holds the box up high. But as you go with a higher and higher print, taller and taller print, then it will just lower down and sit against the floor of the printer and continue catching blobs.
That's really cool.
So here comes another one. Wait just a second. We'll see it flip into the box. So yeah, I want to credit Dendrauen for his Blobifier code. And I probably wasn't the only one who did this for a Trident, because that's the problem with the Trident. is the conventional servo-assisted Blob system relies on a moving gantry, not a moving plate. So this just gets me a solution. What I do give up, I think I probably have this okay now. I can't have anything. Let me stop this now. I can't have anything taller than about 100 millimeters underneath the gantry area where I'm purging.
Mm-hmm.
So that's one restriction to this approach, because I always have to return to the plate to purge. So a really huge, tall part isn't a good solution for this software-only blobifier. But I almost never do multicolor printing on really huge, really tall parts.
Sure.
But maybe if, and there's still a lot of room on my 350 plate out beyond where the gantry is when it purges, that it works fine for me.
Sure. I want to change gears a little bit, Glenn, and ask you just about design in general. I know myself and so much of my audience, we're not engineers, but we want to get better at CAD. And specifically, I think most people, in Tinkercad or whatever can open up and make a little bracket or a one-piece design. But you've created these complex systems of many parts that work together. And I wonder if you could share some tips on how you manage all that, like best practices for organizing your files. How can someone go from, I can make a little bracket to hold my screwdriver, which I think most of us can, to this level of complexity in designing a solution?
Sure. I'll do my best. And no means am I a professional CAD designer. And I started out my career that way.
That's exactly why I'm asking you.
So I'm a hobbyist who's gotten back into it. I've used SolidWorks. I'm currently using Fusion 360, and I have for the last few years. I could get SolidWorks free when I was a robotics mentor, but I can't afford SolidWorks if I'm not a robotics mentor. And I do run the free version of Fusion, and it does what I need it to do just fine. And my initial designs were an absolute grease fire. They were just they were a dumpster fire, in terms of organization of parts and being able to, even look at sketches and understand them and do anything, and tons of errors. I could design, build, and print things and make them work. But as soon as I started needing to share files, then suddenly, if you just have this disaster of a CAD file with no organization, it just doesn't work for other people. So I definitely organize my structure for a multi-part assembly into rational sub-assemblies, and you can create all those as components in whether it's SolidWorks or Fusion 360, and probably Onshape. I've played with Onshape a little bit too. Mm-hmm. I know you like Onshape, and I like a lot of things about Onshape. But think about what your rational sub-assemblies would be. Name them logically. Don't be afraid of creating a lot of sketches. Name your sketches. That was the other thing, because on Fusion it will just be like sketch 1, sketch 2, sketch 3, sketch 4. You get into something really complex and you can't figure out where all that is. But think about, for me, what helps me the most is what I can accomplish in creating that part with the most rational set of sketches, because then being able to go back to those sketches, they're named, they're clearly dimensioned and defined in a rational way. It makes it much easier to tweak and fix things if you can navigate that structure. So the other thing I've ran into, though, and right now the solution for me is just been more firepower, but at some point, if you're doing this off a laptop, and the whole classic design, in fact, both these designs were effectively developed off my laptop. Mm-hmm. I've since gone to a desktop, but at some point you run out of power, computing power, or really probably memory more than anything. If you
Onshape, cloud,
sure, yeah. But Well, it's the memory required local to crunch all this stuff that fits together and kind of has to compute and render out. So I went to a fairly affordable desktop 6 or 8 months ago, just because it makes the whole process go so much faster. But
so those were good tips, though. Those are really good tips. And I guess in Onshape it would be Part Studios, but is the idea there? Let me kind of poke at your suggestion. Is the idea there, rather than having this long history of features for every possible thing in your entire project, the idea is break out each individual piece, and then you have the history, and then it's easier to follow?
Yeah, sort of. It's I do like to maintain, if I can, all the parts and all the histories of a top-level assembly in the same file. You don't have to, but I do. And the reason you wouldn't is if you're running into performance issues.
Sure.
But it is true that if you don't break things into rational sub-assemblies, trying to find a step back in your history, it can be really, really difficult. But if you have, and I will go to a share on the CAD just for a second to prove that point. And we'll go back to the V3 here. So this is the same structure that my STLs are posted on GitHub too. Is there's a drive roller assembly, there's a tensioner assembly, there's a chassis assembly, idler, blah blah blah. So when you're like, and there's a lot here, but it's like, okay, I really want to go back and change something on this idler wheel. It's so much easier to be able to just drop down that assembly and then find those parts than if everything was just a super, super long list of things.
Yeah. I think assemblies for you is Part Studios for me. Maybe. There's a different language, but I think I get what you're saying. By the way, are you using one of those like fancy CAD mouses to be able to make those smooth, fluid motions? Okay.
I am. Yeah, I've had one of these ever since I was doing a lot of CAD in the robotics days. So I've had one.
Amazing. I was like, God, it looks like a professional animation the way you're displaying it for us.
Yeah.
It's one of those fancy mouses. Very cool.
I love it. I can't live without it. I'm spoiled now. I wouldn't want to have to buy one again, but I bought it like 16 years ago. There are some pretty cool projects out there to make your own. I don't know how well they work, but I think teaching.
Yeah, I've been debating. I want one so badly, and they're like $700-800 maybe, I think. And I'm like, I'm all for 3D printed stuff, man. But like something that I manipulate that much, I'd want it to be perfect, not 3D printed with layer lines really and sometimes catches and little stuff like that. What else are you working on right now? Any other projects coming down the way from you?
I am really. I'm trying to not do anything more on Filamentalist. It's pretty solid. I probably at some point need to buckle down and document the Enclosure project to the same degree as the Filamentalist projects are documented. I used Voron standards for both of the Classic and FV3s. There's an assembly video for the Classic. I probably need to do one for the FV3. That's the last stuff you want to do, right? When you're brainstorming, just then go do documentation.
Totally.
But I didn't really expect the Enclosure to be very popular, but actually it turned out to be, surprisingly popular because it's easy to build. You print like 4 big parts, the end caps, and put it together. And you print 4 parts for the hinges, and then the rest of it's just assembly. But a project that it's been on and off the burner, and you can see him a little bit. But I'm building a Micron. So do you see kind of a little R2D2 looking thing?
Yeah.
So
very cool.
It's a tribute, R2D2 tribute Micron. This is a little, you turn his camera dial and the screen will pop up. And
very cool.
Yeah, so that's what I'm doing a little work on right now. And that's a fun project. And I just wanted like a little ripper that would heat up fast. And I mean, once I have this thing running, probably the majority of my parts I'll just be building off the Micron.
Yeah.
And then I also plan to do an MMU system for it. Kinematic Digit has something called the Angry Beaver, and we'll just leave the name at that. Um, and uh, and then IGN AUKUS did something similar where he just hung like almost like little extruder modules right off the back of his Filamentalist enclosure. So you just have a drive lane, motorized drive lane for each filament, and then you use a downstream combiner. And the benefit of the downstream combiner is, and I think that's how Bamboo more or less does it, but the benefit of that is just less to eject, right? The closer you can get that combiner to your extruder, you can get to very quick swaps. And you can still use a Filamentalist and something like that. If you're only ejecting 100 millimeters, you don't need it. A little bit of slack on your spool is not going to hurt anything. And there are some little buffer expander solutions out there too. But if you have to eject 400 or 500 millimeters, then a system like that can also run with the Filamentalist. So I'm planning on giving R2D2 a little domed head and have 4 spools running up top, and then some other, just for the fun of running some other kind of MMU, some other MMU design. Box turtle is really cool. It'd be kind of cool to mod a box turtle to be an R2D2 dome. There is a solution called Quattro Box that uses the Filamentalist. It has Filamentalist inside. Cool. That's also, would be a good solution for this next little printer.
Random Joe Gamer asks, how do we continue to follow you on this project? I assume R2D2. Are you documenting it somewhere on your Discord?
I do. It's on the Micron Discord, and I started a build log on it, and I kind of I'm saving it. I started it last winter, and then in the summers were off camping and hiking and fishing and doing all kinds of stuff, and I can easily become immersed in a project and let an entire summer just like go by without ever leaving the house. So totally. I've told myself I'm not touching this thing again until ski season, because ski season I'll be home each day, and then I can work in the evenings. But I don't. I'm trying to purposely avoid it right now. So cool. It is over on the Micron Discord, and there's a build log under the Doom Cube. This will be a Doom build, and somebody else some years ago did an amazing droid Micron build, and he's like weathered. He has like rust stains. He looks like he's been through battle. His legs articulate. Cool. He'll tilt back, and you can print tilted back. Why you want to do that, I don't know. But somebody pointed that one out. This one's more of just a clean homage to R2D2.
It's very cool, man. It's very cool. Well, hey, I really appreciate everything you do for the community. I know many other people do in the chat and at large. And I'm really excited just to see the other stuff you create. I have a feeling that this isn't your first, this isn't your last contribution to open source 3D printing. And so I'm excited just to follow the cool stuff that you're doing. I like the way your mind works. So, yeah.
Well, thanks, Jonathan. And, it's I really have loved the communities out there. For me, it is a way to give back. I have not tried to monetize this. It's kind of like, if I wanted to do stuff for money, I wouldn't have retired early. I would have just stayed in my good paying job, Yeah. And so, there are some kits out there, and kit vendors try to give me a small percentage, and then I just roll that back into the guys, the ERCF dev team.
Very cool.
Because it's a small amount, and I appreciate everything they've done. So I do this kind of for the joy of innovation and all the smart and nice people I've met through the communities.
Amazing. And we need to do that because open source 3D printing is in danger. And on the one hand, there's the school of thought of like, it served its purpose. Now, there's big VC bucks building on top of the cool innovations. But there's also like, there's the spirit of it and the community and the innovation and the challenge that I want, even if we get to a point, right, where commercial printers are just better because they're using technologies that we don't have access to. I still want that spirit to live, and I still look at it as kind of like you mentioned Formula One earlier. It's the Formula One, right? Like, we're doing weird esoteric stuff. Wouldn't surprise me if we see a one-way bearing in a future product from one of these big companies. So I hope it stays alive, and we need to support each other.
Yeah, I agree, and I also agree that I could probably go buy an off-the-shelf printer today that would probably print a little better somehow, or ease of use or whatever. But I really enjoy problem solving. I'm kind of a problem solving junkie. And so this hobby has allowed me to solve problems through a little bit of code in a config file or through a mechanical design like that Blobifier articulated arm thing. And I get a lot of personal gratification reward out of that, and it's fun to share, and it's fun to learn from others while sharing. So I can hardly imagine not having my next printer and my next printer after that be one that I don't build. It's just hard for me to imagine, because basically I'm giving up a huge part of the hobby just to have something to print things. And honestly, I love the design process, and I love the problem solving process so much that I can't see me letting that go.
Well, very cool. Well, Glenn, thank you so much for coming on today, and let's keep in touch. And I look forward to everything that you publish, especially the R2D2.
All right, thanks, Jonathan. Pleasure to be here. Bye.
Take care, everyone. Thanks for tuning in. Bye.
Thanks for tuning in to the Infill Podcast. For show notes or links to anything mentioned in today's episode, visit thenextlayer.com. If you enjoyed the episode, please don't forget to leave us a review wherever you're listening, or click the like button to let us know. And consider subscribing to The Next Layer on YouTube so you can tune in live and participate in the next conversation. We'll see you on The Next Layer.